Okay, so in this video we're going to look at the simple rules for differentiating the different types of functions you're going to see in A2 maths. So we're going to look at the e, the bracket, the trig, and then the log and the inverse trig as well. Okay, so first one, e to the power 5x over 6. So let's call that y equals. So we can write down dy by dx equals. Now, with all of these, you could do the chain rule, but that's going to take you a little bit longer. So I'm just going to explain and remind you of the quicker way to do this without having to go through the chain rule steps. So for the e function, you keep the e function exactly as it is, but what you do is work out what you get when you differentiate the power, and then that comes to the front as a multiplication factor. So the differential here of 5x over 6 would be 5/6. So you can't ignore the 6 and just think the differentials are 5. Here the differential is 5/6. Therefore, we can just write that at the front, and then our e keeps the same power that it started with. Okay, that's that one done. The next one is a cube root of 8x plus 1. So let's rewrite that as a bracket to start with. So that would be power 1/3. Sometimes your bracket is in the bottom on a denominator, in which case hop it up to the top and give it a minus power. This one isn't, but we did need to rewrite it as power 1/3. So then the quick rule for differentiating your bracket. You bring the power of the bracket down to the front. So again, you're multiplying. You drop your bracket by 1 complete power, just like the differentiation you have in AS. But what you also have to do is multiply by the differential of the inside. In this case, the differential is just going to be an 8. Sometimes the differential is going to be something to do with x as well. But here this is just quite a simple linear bracket, so the differential is just a number. So as we write the answer, power to the front, keep the bracket, but drop the power by 1. So here we're going to go down to negative 2/3 and multiply by the differential of the inside. Now it's probably sensible just to times those together. I'm not going to bother trying to rewrite the bracket with the power minus 2/3. I could pop it onto the bottom and say positive 2/3 power on the denominator, but I'm not going to bother. That's fine as it is. Okay, third one, trig. So you need to remember the differentials for sine and for cos. The other differentials are in the formula book. Okay, so when you look at your page in your formula book, you have your differentials for tan, for sec, for cot, for cosec, so you can use those if you need them. But you need to know that sine differentiates to cos and cos differentiates to negative sine. So then if you have something with the angle so it's not plain sine x, you've got to think about the angle as well. So what happens is you multiply by the differential of the angle. So again, we're multiplying by differentials with all of these questions. Okay, so we can write our answer down. The differential of x over 4 is going to be 1/4. So that comes to the front and multiplies. Sine differentiates to cos, and the angle doesn't change. Okay, so stick to that rule whenever you're differentiating any type of trig. Put the differential of the angle at the front, turn your trig word into whatever it differentiates to, and keep your angle the same. Okay, let's have a look at 3 more. So the next example is a log. Okay, so if I put y equals here, we need to know that ln x differentiates to 1 over x, and that's the simplest log to remember the differential for. When you've got log, natural log of something more complicated, again, there is a quick way of doing it without having to go through the chain rule. We are going to end up with a fraction that has the original function on the denominator and then just the differential of that function is a timesing factor. Okay, so it's going to times and it's going to end up on the top. So the differential of 2x squared is 4x. The differential there is minus 3. The 4 disappears. So effectively we are multiplying by our differential. Okay, but we're just sitting it on the top of the fraction. Do not be tempted to cancel anything out of that. There's no common factor that everything has in common, so just leave it alone. Okay, the next two, they're slightly more unusual. You may not get an inverse trig at all, but if you do, you have the answers to inverse sine, cos and tan in the formula book here. But obviously this is just for plain x, and the questions I've put here have got a something x in there. Okay, so you could memorize the quick way. To be honest, most of the time I just sort of think, let's just do the chain rule. If you get one of these, because maybe it's not there, it's not going to come up often enough to make it important enough for you to have memorized the quick way. So let's use this as an example of the chain rule. So the chain rule idea is where you let one letter stand for a more complicated bit. So here we've got u equals 3x and y is inverse tan of u. We know we can differentiate to get du by dx is 3. And then if we differentiate this one, we're going to have to differentiate using u's. So that would become dy by du. And then we can copy the answer for the differential of tan. Look, there it is. But we're going to put a u in place. So that's going to be 1 over 1 plus u squared. Okay. Then your chain rule multiplies these together. So dy by du multiplied by du by dx. And you will get 1 over 1 plus u squared multiplied by a 3. So the 3 sits on the top. And then what we need to do right at the very end is replace the u back with the 3x. Pop it in a bracket. Don't make a mistake at the very last and miss the bracket off, because that squaring is applying to the 3 as well as the x. So there our answer is 3 over 1 plus 9x squared. Okay. And we can do the same process with the other one, the inverse sine. So if we let u equal 7x and y be inverse sine u, then we have du by dx is 7, and then copying from the formula book the differential of inverse sine, look there, okay, but we're going to put a u in place. So 1 over square root 1 minus u squared. Okay, chain rule, same chain rule again. dy by du, I'll just write the answers in. Multiplied by du by dx, so that 7 ends up on the top. Replace the u, remember a bracket, and you can then square the 7 and square the x. So these two are more unusual questions. Okay, you're going to learn your other 4 basic rules though. The log rule, okay, the differential over the original, and then going back to these, the bracket where you bring the differential down to the front, keep the e the same. Sorry, that was the e. The bracket where you bring the power to the front, drop the bracket power by 1 and times by the differential of the inside. And the trig where you multiply by the differential of the angle, change the trig word, keep the angle the same. Okay, so you need to know all of those different techniques.